Det är en flygbild från 50-talet. Nej, jag tror att det är en sån att någon flög och sålde bilder bara. Ja, Daniel. Jag tänkte, du behöver inte. Ja, det är det. No, now I'm here. I will not leave this. I will take over now. So I will do like. Yeah. Ja. Ja, jag håller på i en kvart hur som helst. Men istället för dumma frågor kan jag fortsätta i 5 minuter och prata istället. Det kändes som att det var lite mycket frågor och grejer sist. Och lite presentation. Första. Gjorde du inte det? Nej, hallå. Vi ska prata. Mm.
Men jag kunde ju ha låtit dem få mera frågor från publiken var och en. Men vi startade 10 minuter så jag vågade det.
Nej, det är lätt hänt. Alla går och dräller.
That's a good.
Mm.
Sett den här bilden som har gått.
Mm. Men den har du inte sett, tror jag. Men du har sett någon liknande?
Ja, men, okej,
Typ
det där
någonstans.
Är för länge sedan, eller?
Ja. Flyg 50-talet.
Ja. Nej, men jag har sett bild på din gård. Jag kunde se att det är din gård.
Ja,
Bara det.
ja precis. Ja. Ja, men där känner jag. Fast den är utbyggd nu då. Den är utbyggd. Så det där huset där, det är ju lite större. Mittenhuset där, så att det har byggts ut mot ladan. Och så bak så har det byggts ut ett så också. Så det är som ett L här. Så det är dubbelt så stort. Typ.
Jag såg bilden i december. Så.
Ja, den dyker upp här sen. Mm.
Så den tillhörde din familj då? Nej.
Nej, ja.
Har du köpt det?
Vi köpte det 2015. Eller 14 köpte vi. Sen flyttade vi in 2015. Nej, vi köpte det 2015 måste det ha varit. Och så flyttade vi in 2005.
Jag såg åt dem som ansvariga och bjuda in.
Mm.
So we start in 1 minute. 1 minute. Jag tyckte det lät lite fjösigt i förmiddags när jag satt där och tänkte, hör de det bak? Men det kanske finns högtalare där. Jag tycker fortfarande det hörs fjösigt så här. Hör de där bak?
Jo, men det är så.
Var satt du? Satt du lite...
Jag satt nog där. Typ. Det funkar. Det var ju högtalare hela vägen. Ja, det funkar.
Okay, so could you please sit down if you are entering? We will start. I expect that most of you were here in the morning, and we will run this session in a similar manner, but perhaps some of you weren't. So I'm going to tell you what will happen in the next 1.5 hours. So I'm the session chair, and my name is Daniel Pargman, and I come from KTH Royal Institute of Technology in Stockholm. And we will have 4 presentations in the afternoon session. And basically they each have 10 minutes to present, and then a few minutes for questions, perhaps clarifications. And at the end, we will have half an hour. And I would again ask everyone in the audience, as well as the authors of the papers, to listen to each other's presentations, and for you to listen to all of them and to listen with attention. And also perhaps think about questions. And you will get bonus points if you can find connections between presentations and manage to pose a question tying 2 or more papers together. That would be wonderful. That's probably all we need to know for now, or we will get back to the question session later. We have 2 runners here, also 2 student volunteers, Vladimir and Arthur. Yeah, okay, they will cover half of the room each. So the first presentation is Jens Malmodin, and this is the longest title, Just Measure It, Electricity Consumption, Measurements of Electronic Devices and Estimates of Data Center and Network Services for one household. All that text for one household.
Yeah. Great. So I start? All right.
Yes,
Thank
welcome.
you.
Welcome.
Jens from Ericsson, the Swedish company. So I measured all electronic devices in my household, which I will talk about. I used to talk about, I've written a few papers about the global ICT. So now we are more down to earth, just my household. But it's really interesting. Just Measure It is the short title. So once upon a time, I measured the standby of my own mobile charger. So long story short, after a few years, Ericsson shipped like 40 million mobile phones with smart chargers. What gets measured gets done, as they say. So this was a really good, lucky measurement. And today they are cut by a further 90%. So, I mean, the power consumption was cut by 90%. An inspiring study for my work was the Swedish study of, the key here is the 40 household measure for a whole year. So if you want to measure the energy consumption of a device, you need to measure it over quite a long time. Well, the whole year, actually. So that's what I started to do. What they found out in the old Swedish study was that standby consumption of PCs, TVs was still high. And this was like nearly 10 years after we had done our little work. 4 PCs, TVs used for 20 hours, consuming 800 kilowatt hours. So this is the results compared to what I have measured now. So I can safely say, I think, that PCs and TVs, the standby is now fixed. They're all under half a watt. 0.3 watt seems to be the magic number here. Nearly the same consumption PCs, TVs. We have nearly twice as many, but I mean, you can only use them for that amount of time. So it's still like 20 hours of use. We also have 4 smartphones used also nearly 20 hours. Half of that time is actually with screen shut down, Spotify's music streaming. I will try to do this very fast here. So this is the results. Number 1 consumer, my son's gaming PC, 350 kilowatt hours. Number 2, the living room TV we all use. And you see the usage hours there. And number 3 is actually the home network. And we don't have only one box, we have 3 boxes, and they consume 300 kilowatt hours together. And all other devices consume almost the same. Another way maybe you will remember is the home network, TV and PC, the gaming PC, and all other devices together. It's like 1 solar panel each, actually. Slightly more than 300 kilowatt hours, around that. And then I also estimate the data center service and network services for the household. They are also like 1 solar panel each, so 5.5 solar panels. I will not have time to go into all this, but I mean, the networks, one subscriber, mobile subscriber, average in Sweden 40 kilowatt hours times 4, 160 kilowatt hours. The fixed, including the home network, is about 2 times as much. Without the extra routers we have, that would be a fairly, the same. Estimated data centers, you can just take the Facebook, any consumption, divide by number of users, and then we multiply with number of users in the household. Note here that Akamai and Netflix platform, they put out nearly 30% of all data, but consume only 0.5% of the world data center electricity. So fairly efficient related to amount of data. This is how I measure it. You have the Bluetooth smart plug. I use Bluetooth to not interfere with the Wi-Fi, consume 0.5 watt. And then you have the professional multimeter. That was crucial for the project because then I can check that all measurements are accurate. And this is how it looks like in the smart app. You have the power meter, and then you see, I can correct it with the professional meter there. This is how it looks like when all meters were on, measuring the home network, TVs, and so on. And here you see my work PC. This is it's before lunch. So 2 hours of ordinary work and 2 hours of video conferencing. So video conferencing, my setup consumes 5 watt extra. And you see a cup of coffee adds actually 10 times as much. It adds about 50 watt hours. So you boil 0.5 liter of water, that's 50 watt hours. Of course, video conference, of course, coffee. The reductions here, potential are very low. Very boring measurement, the home, the fiber modem and router. It's like a flat line, but something happens here. Here you actually see 6 months of measurements. So 1 month ago, there was an update on the software there. So it looks like it tries to save some energy. Not that successful, a few %, but something. They're doing something there. This is how it looks like. You have the desktop gaming PC. You see there's certain levels. It depends on what game my son plays. So you have the first-person shooters up there at 250 watts. The TV is like 120 to 170 watts, 140 watts about average. And my work PC with the display is very stable. I have to talk a little bit about this. When you measure your home router and you look at the average data traffic, you see we consume about 1 gigabyte per hour on average. So if we turn this to a measurement, watt hour per gigabyte, and we try to estimate other use with other data rates, all the way up to downloading a PC game with full speeds, over 400 megabits per second, we got these watt figures. But actually, since I have this measurement ongoing all the time, I can see, that's not how this network equipment works. They're pretty much stable on all the time to be able to provide very fast data rates. And then to this main router, there's about 15 to 20 devices always connected, depending on how you look at it. I should probably also say that, if you try to do the same download over Wi-Fi, it consumes a little bit more. About 2.5 watts if you have a very good signal, and up to 5.5 watts I measured with a poor signal. So that was me running around the corner, hiding in there and trying to do that. And then the data rate drops below, so I miss a few megabits per second there. If you look at it from how it looks like from my end, there you have my home network, and then we deployed the fiber modem last summer, and I was like kind of a geek. I went to them and made them open the cabinet and discussed all the technical details. I know how the network works. I also called the owner of the access network in the small town. But they thought, funny, someone who's interested in this. So when you're streaming then, there's been a lot of talk about this, and it still is. This is how I see it, what will happen. I look at all the Netflix figures from Netflix. So on average, when I stream, it's about 2 watts in their data center, also including the Amazon platform they're using. And I only measure like plus 0.1 watts. That's like the average number when you do something. Doesn't matter what. And here we are actually talking about in the order of 10 megabit per second. So we are only using like a % or 2 of the capacity of the network connection. The good thing with streaming is that you can actually, you are not locked to your TV. So you can stream to a smartphone, and then you can save a lot of energy compared to the TV. Compared to cable TV, which we have never had, but I used to have it back in the days. And one connection consumed 20 watts. The thing with this one is you can only do TV. The thing with the fiber is that you can do everything, also TV on top, for actually a little bit less power. However, beware, there's, as I say, you can find incorrect information about the internet on the internet. For example, streaming. So there's figures you can find from anywhere, 100 watts, that's the Carbon Trust white paper they have, up to like several thousands of watts. 6,000 watts was that figure I found. But beware, this is, if you go in here and measure things when you're streaming, this is what you will record, so only a few watts. And I should say, this is how I measured after 2 months, which the paper is based upon. You see the dark green, what I measured, then you extrapolate to full year. But now I have measured for 6 months. Not everything exactly, but you see the, and maybe not a surprise, the figure still stands it's almost the same total, but we watch a little bit less TV and use the PCs a little bit more. And I think the reason for that was, there was a World Cup in football when I did the measurements. So we watched more TV than I did, at least. And in the end, I think I also, sometimes I add too much in my papers, I know that, but I also added the carbon footprint. That's typically the first question, what about? So for us in Sweden, with a green electricity mix, that will not be much, 50 kilos. If it was run on world average electricity, it will be a ton. But the embodied footprint, so I went down like 20 years ago and looked, how much have we bought and how much? So it looks to be, yeah, it's a smartphone. We have 4 years, seems to be the average lifetime. So we buy one every year, one laptop every year, if you include also the work and school laptops. And then, yeah, that's it. This is per year, but me flying here, I'm sorry, I've flown here, it's the same footprint. So. Reductions, we can buy a new TV that consumes half. We can also skip all the Wi-Fi and go for a fixed network, but I think that's problematic because it's very hard to even get those kind of devices because the operators, we are kind of locked into their box and so on. So not much, you can also buy a very large TV with very high quality, 8K and high dynamic range, a lot of brightness. Then we can consume double. However, the thing I have done in my home, I switch heating equipment, save 12,000 kilowatt hours per year. And of course, the solar panels add 20,000. So in comparison, it's not much. And then everybody's over 18 here, good, because meet Lilith. I'm sorry, but she's the reason I need to buy this new gaming PC. I know, but the old one is like 8 years. It cannot handle the graphic, this new game. So but it connects to a lot of things said. I'm sorry. Thank you.
Thank you. I just have to ask, you said that it was your son playing, but now it seemed like it was you. So what is it?
I haven't been playing actually, but this is a game I have always played since I was 20 years ago. So it's a new game. It's released today.
Which game is it then?
It's Diablo 4.
Okay. Diablo 4.
Yeah.
Okay, so that was a very data-intensive presentation. Also, we learned a lot about the Malmudin household. You can read the paper and perhaps an interesting exercise in self-surveillance.
Yeah,
Yeah.
And I actually made my family sign the GDPR, so that it's a... Because, and Dag, he reminded me, actually, because we had this...
He did.
Are you allowed to use their... Well, maybe not. Maybe I should, yeah.
Okay, well, anyway, we will have time to talk more afterwards, but perhaps there is one or two quick questions, perhaps clarifications. There were a lot of data. I see 3 hands, so let's see. There was 1, 2, 3, and please state your name and your affiliation, and then your question.
So, François Tajani from University of Rennes. I have a question about fun and gaming. So, a couple of weeks ago, the last Zelda came out, and in my family, we decided to play Zelda 1, which is still available, and we had fun. So do you think that the younger generation can be convinced to have fun on very old games, or is it just too much to ask?
No, I mean, we have a Nintendo Wii, or we use, but we don't, that's still around, and that one consumed like 1/10 of a gaming PC, and then the whole family can play from the couch. So of course it's... But I take the question to my son, because when I asked him about this, are you prepared to play less? And he was like, probably not. Why that? Because I've saved energy, but no, it was not on the... and of course, I mean, when you compare to other things, you can, maybe it's not that big of a thing if you do it a few years when you are at a certain age and so on.
Before the next question, could you unplug your computer so the next speaker can, while we take the last 2 questions? Oh.
What happens now? Will it work?
We'll see. Yeah, perhaps you can start.
Thank you very much, Jens. My name is Daniel Sheen from the University of Bristol. Really interesting presentation. What I liked about it was putting into perspective the energy consumption of your household electric ICT devices with the energy that your home generates from solar PV panels. Could you go back to this slide? And I wonder if the entire energy consumption of all of the devices was visualized as a portion there. Yes, it was. Okay.
Yeah.
So how many panels? These are 6 panels and each about 300 watt peak
Yeah,
output?
yeah.
Okay.
No, it's the actual produced electricity last year. So 21,400.
Okay, so you've got annual
the
energy
annual
consumption
production
there.
So one panel meets the annual need for, but of course it's not. It's mainly in the summer, of course. In Sweden.
So I haven't got the answer to this, but an interesting question that one could exercise is how achievable is it to satisfy all households' ICT demand with local solar PV deployments? That would be one question. And then related to this also, if you go back to the last slide on the embodied impact. Just the one before, yeah, exactly. Do we have, okay, great. We've got so interesting that we're seeing the use phase electricity consumption in the context of Sweden with very low carbon intensity, and many countries are also on the trajectory of decarbonizing their electricity mix. Hopefully going towards that. The embodied impact becomes really, really important. And this is just on the annual level here. So that's a really important consideration that comes out very clearly here.
I think an average Swede, including all the consumption, what's like produced outside but imported to Sweden, is about 10 tons of CO2. So we have 4 in the family, like 40 tons. That's the total.
Yeah, I think that is fairly representative
so this is like
of your
a little bit more than 1%.
EU average. Yes. Yeah. Okay, great. That's interesting to have those numbers, even though we're blown away by the sheer number of numbers. Thanks a lot.
That's my trick, you know.
So we have the last question from over there, Adrian. Yes.
Hi, Adrian Friday, Lancaster University. Thanks, Jens. I really enjoyed your autoethnography, quantitative that is. So I wanted to ask you a qualitative question. You've been logging long enough now to understand that it's the infrastructure change that leads to the demand over time. And you had that really nice trade-off of if I buy a new gaming PC, you know, it's going to add 250 watt hours or whatever. Has this changed how often you think about upgrading stuff and what the impact is going to be in your house? That's my question, really.
Yeah, I checked new TVs because the TV is nearly 8 years old now, but it's still working. So we will keep it, and nobody in the family. I mean, the TV is it's working. It's no problem. And when we buy a new one, I will make sure it consumes half of what this one consumes, because we have a just slightly smaller TV that's not hardly ever used. The second TV is hardly ever used anymore. And that consumes only half because it's a bit newer. So, and they did something great there between the generations there. So that is one thing. When it comes to gaming PCs, no, I don't negotiate anything there. There has to be in the top level.
Then the children have the power, I think. Yeah. Okay. No, that's great. Thank you.
Yep.
Okay, thank you very much, Jens. So if you were here in the morning, you know that there are papers and then there are journals first presentations. So this is a presentation by Adel Noureddin, the impact of green feedback on user software usage, and it has been published in a journal and is now presented. It was published in IEEE Transactions on Sustainable Computing.
Yes,
right?
Exactly.
Yeah. Okay, so welcome.
Thank you. So I'm going to continue what the first presentation about measuring. Now, what could we do with this measurement? So this presentation will explain a study we did with end users, where we try to show them their energy consumption in real time and to study their behavior. What do they do with this metric? Did we manage to raise their awareness? Did they change their behavior in terms of using software in a desktop environment? So a little bit about me. I'm an associate professor in University of Po. And I work on green IT since many years ago in software engineering and autonomic computing. And the context of this study, because I work a lot on software measurement tools and factors impacting software energy, so really from the software engineering community. And in this community, we tend to develop technical solutions, optimizations. We tend to maybe, when we include a human in the loop, it's always a developer or a system administrator. But we rarely involve end users in optimizing our software and their energy impact. And I think the next shift should be including these end users and pushing them to change their behavior. So using software differently or a different set of software. And to be able to do so, we need end users to understand the impact of software. Because I can ask you a question: what is software? What is software energy? Just a simple question like this. For anyone who is not technical or tech-savvy people, it is difficult to understand that an abstract concept like an idea, like an instruction, like a software, have an impact on energy consumption. So our question was, if we raise the energy, the user awareness in terms of energy consumption of software through live feedback, live green feedback, and I'll show you an example of this feedback, will this push end users to change their behavior in using software? So we need to understand what do they know about software energy, what is their perception in general about software and energy, and will this feedback push to a behavioral change? So what we did is, in software engineering, it's a first of its kind study because we did a full, what we call quantitative study with a control group with 100 users. And we wanted to study the short-term behavioral change of end users. So in a 2-hour session of monitoring. And we collected through a survey their perception and their user awareness after the experiment. So what I mean by a visual feedback is this particular tool. So they had to install a few software, including this feedback tool, which shows three metrics. So the power consumption in watts at the lower end, the equivalent in price, and the equivalent in CO2 emissions. But we also showed a visual graph, which is an evolving chart, so end users can see if there is any spike in energy consumption. And we wanted to see which of these metrics or this visual feedback is more useful for pushing for pushing behavioral change. So we had roughly 100 users, so half of them were in the control group, which they didn't have this visual feedback. They were mostly computer science students in the final year, a third female, two-thirds males. But we had the same distribution between the control group and the treatment group. And they had us to do the similar workload. So everyone had a research project to do during a 2-hour session in class using online resources. And we collected metrics. We collected power consumption for everyone, CO2 emission, electricity cost, but also which software they were using and which was the active window. So we can observe if they change the software or change the window or do something else. And the treatment group, the one with the visual feedback, had to install the visual feedback too. We also had a questionnaire at the end where we collected the perception, what they about the experiment, about the software they used, which one consumed, in their opinion, most of the energy. So they had to rate multiple software. And for the treatment group, the perception of the visual feedback. Was it useful? Was it annoying? So this is our experimental methodology. Basically, we had to ask them if they want to participate or not, because they could decline. And if they accepted, they had a guide to install all the tools. So they knew what they were going to do. And depending which group they were in, they had to install a few additional software and then fill the questionnaire and then send us back the data. So they could check at the end the data. Okay, so when we did all of this, we ended up with 52 valid data out of the 95, 26 of each group. And so the results are based on this data. The majority were on Windows, with Intel processors. And yeah. So what did we learn from this experiment? The first observation is that users tend to underestimate their energy consumption, whether in treatment group or the control group. We also observed that these were computer science students, so for them the operating system was the main culprit, and they think it's the most consuming energy. And we attribute that to lagging in the operating system. They had a lot of software installed and used at the same time, so they perceive that if it's slow, it means it's consuming more energy. Also, all the programming and like Eclipse, IDE, or all the programming tools and communication program like Zoom or Teams are also perceived as high consuming because they use a lot of RAM, they lag on the machine. But they understand that the energy consumption is not just on their device, because they were using online resources, that all the cloud infrastructure have a big impact on energy consumption. Regarding the feedback, we observed that it was helpful. They were aware that they are consuming energy. They saw that sometimes there is a spike in energy consumption. But it was quite distracting, this visual tool, because they couldn't minimize it, they couldn't close it. It was always on at the bottom of their screen. For them, also the metaphor, the chart, the evolving chart was more useful because we observed a few users trying to change their behavior when there is a spike in energy consumption, rather than when the chart was flat. And the most important lessons is that they resist any change when they were doing important tasks. So mainly at the end of the session, when they had to give back their workload, their classes, I mean, the report they had written, they didn't care if there is a spike or not. And most importantly for us is, even when they tried to change their behavior, they didn't know what to do. And well, I have a couple of graphs. They don't show much, but what we see here is that some people stated they changed their behavior when there is a spike in energy consumption. Here we see the spikes of energy consumption. And when we observe what they did, sometimes they just minimize the window, they switch from Chrome to another software, but it didn't have any impact on energy consumption. So all the actions they try to apply have no impact on software energy consumption, unfortunately. So what we can conclude is the feedback is useful to raise awareness. The feedback is useful to let people want to change their behavior, but they don't know what to do. They need guidance. We need to tell them that, okay, now you use a lot of energy in the software, you need to change software or to use it differently. So they lack this knowledge to apply these software behavioral changes. And obviously that they resist any change if the perceived workload is very important for them. That's why they don't care about energy. So what we're aiming for in the future, this is the last slide, we want to study additional metrics, additional metaphors, because here we had only 3 metrics and 1 metaphor. And more importantly, we want to produce some guides and techniques to help users understand what to do, and we want to automate these recommendations. And this is what we're trying to do with the Behave project, which we started recently. If you're interested, you have the website. We just started a few months ago. Thank you.
Thank you. Okay, so now I get a bonus point because there's a connection here between the non-negotiable behavior of this important work. They don't care about the energy consumption, and playing computer games in the Malmodin household is also non-negotiable. Just one more reflection, actually. You said that when it sort of gives them feedback that they use a lot of energy, they don't know what to do. When I was a student, I know what I would have done. I would have turned off the computer and gone to the pub. Yeah. Anyway, maybe. So we have time possibly for 1 or 2 questions. It took a bit of time with 3. So do we have any questions? I see 1 hand over there and 1 hand over there. Okay, so 3rd row, Vlad.
Hi, thanks for the talk, Vlad Koram at U Berlin. 2 short questions. First one, what could they have done to save energy short of changing editor, operating system, or their computer altogether? And secondly, you did... maybe I missed it. I didn't see the sort of relative changes, or you just measured the intention, not the savings themselves.
Okay.
And if you did measure changes, how did you control the Hawthorne effect?
So what we measured is the power consumption of the computer. This is what you see here, and the software used, and what is the active window. So when they say they change something, they change the behavior, it's usually, what we could observe is just changing a different software, launching, starting, or closing a software, or changing a window. And we can map it to the power consumption to see if it had an impact or not. And regarding the first question, what could they have done? We specifically in the study, we didn't want to influence them with any recommendation or advice. We wanted to see just if we provided them with a feedback, will they care? And will they try to do something? And they care, they want to do something, but they don't know what to do. That's the takeaway, if you want, in a couple of words.
Could I ask you also to unplug the computer so the next speaker can connect while we take the second and last question over there? June? Yeah. And please say who you are and where you're from.
Hi. First, thank you for the presentation. My name is June Salou, TU Delft, Netherlands. I had a question. Is like, okay, you mentioned that the study was done with students. how do you feel those results and lesson learned would maybe change if it was like kind of practitioners, especially, for example, the fact that they don't know how to change their behavior? Maybe practitioners would know. Thanks.
Yes, that's one of the aims of our project, Behave project we started. We want to expand to other social demographic groups. In this study, we didn't want to make any assumption that they know or don't know. If we have practitioners, maybe they don't know what to do. I mean, we're making an assumption that because they're practitioners, they know that if they close the clips and launch, I don't know, Visual Studio, that will reduce energy consumption. So until we study it, I cannot answer scientifically this question. But we think that, yes, if they are more tech savvy, they might have some hints that this software is using more resources and therefore consuming more. But at the end, and this is what the conclusion is also, if the task is important, if they are doing actual workload, they won't really change and handicap the workload to lower just energy consumption.
Thank you very much.
Thank you.
Okay, so we have our third presentation, and it's Matthias Martinez, you can see over there. This wins the prize for most number of authors in this session. 8 authors, of which the 7th out of 8 authors will present evolution of Kotlin apps in terms of energy consumption, an exploratory study. So, please.
Thanks a lot. So, hello, my name is Matthias Martinez from the University Polytechnic Catalunya. And I have done this experiment with the collaboration of Ivano Manavolta and Gianluca Scosia, and with the help of this number of 6 students or 5 students from the University of Amsterdam. They help. Yeah, sorry, sorry for the mistake. So they help us with this experiment. So before to start, I want to clarify what is Kotlin, because it's in the title, but many people don't know what is Kotlin actually. Kotlin is a programming language that was introduced like 10 years ago, and actually it became very famous because it mixes different programming paradigms like object-oriented programming, functional programming, and also the source code is compiled to the Java virtual machine infrastructure. Okay, that means that Kotlin is fully interoperable with Java. So both Java and Kotlin code runs on the Java virtual machine. So why we are discussing about Kotlin? Okay, because Kotlin is used for programming Android applications. So actually, if you have some applications from Meta, from Facebook, most of those applications have been migrating from Java to Kotlin. Okay, so some years ago, Kotlin became the main programming languages for Android, so was adopted by Google as official programming languages for Android applications. So there are many developers that have migrated their applications initially written in Java to Kotlin. And others developers have started writing their application from scratch in Kotlin. Okay? So some years ago, we have done a study in the adoption of Kotlin in open source applications, Android application in particular, and we have found that around the 11% of the applications were written in Kotlin. Actually, they have at least some part of the application written in Kotlin, because for some applications, we can mix Java and Kotlin. So we can see that here, the distribution of the amount of code, that there are a lot of applications that are mostly written in Kotlin, and there are some applications that mix Java and Kotlin. And we have seen different trends. Applications that are initially written in Java and they migrate to Kotlin. So in this paper, we wanted to know the energy consumed of those applications in the process of migration, and actually in the evolution of these applications. So if we have different versions of one application, written in Java or in Kotlin, we wanted to measure the energy consumption of those applications to know whether the use of Kotlin increase the energy consumption or not. So in this study, we focus on Android applications. So we focus on open source applications because the reason is that we can inspect the code that is behind. So we focus on Kotlin applications, most of the code written in Kotlin. We try to select applications with a good test cases. So to be sure that we take application that has good quality, active development, and with at least 10 releases that means the release is an APK file, okay? Finally, we choose 3 applications. So here the Wi-Fi analyzer with 11 applications, 11 release, in Habit and Anki Android. So once we have the 3 applications at the different release, we actually write some scenarios for testing each of the main functionality of those applications. Then we execute the scenarios and measure the energy consumed by running these scenarios. And then we analyze the energy consumed along the history, that means on each release, and we detect or analyze all the spikes and drops in the energy consumption. And finally, each time that we found a spike and a drop, we analyze the release note to understand what is happening, why it produced a spike in the consumption from one release to another one. And here are the results. I will split the results in 3, one for each application. This is the plot of the energy consumed by this application. The first one that is the Wi-Fi analyzer. So we can see that actually we have an upward trend in the energy consumptions. Here in this part of the history, each point is the energy consumed by one release, okay? Here we can see that there were the migration from Java to Kotlin. And here we observe that the migration from Java to Kotlin did not affect the energy consumed by the application, okay? However, here we see that there is a spike on the energy consumed by the application. Here in this case, we inspect the changes that were introduced by this revision. We didn't find any major change, any new features. However, one thing that we have seen is that in that version, they have upgraded the Android, they have added support for a new version of Android. So, and according with some papers, some related papers, that they say that that may be a source of energy consumption. So that can explain the spike, but we cannot assure that this is the main reason. For the second application, here we see that the migration takes some release to be complete. So here we have observed different spikes and drops, okay? For instance, here in this spike, we have seen that the developer have introduced a new feature, and that feature consumed a lot of energy that were removed in the next version, okay? And then was introduced here later, but we can see that here the introduction, that they fixed the problem that they had this new feature and consume less. And finally, here, this application that we can see that the migration took longer, we observed that there were a lot of spikes here in the energy consumption. Here in the migration, the developers have tested different features, migrate, doing some trials, we can say. And they have, for instance, at the beginning, they have done a lot of improvement that can reduce the energy consumed by these applications. For instance, for improving some animations and remove some GIFs that consume a lot of energy. So, in general, to conclude, we have seen in this preliminary study, we analyzed 3 applications. We would like to analyze more applications to see more different cases. But in general, we have seen an upward trend in the energy consumption. So we would like to study which are the, more in fine grain, which are the roots of these energy spikes. For instance, whether the introduction of Kotlin, of the use of Kotlin impacted energy, because right now we cannot assure that the introduction of Kotlin have an impact on the energy of the applications. And of course, we need to use more applications for test the energy consumed by one application before that the application is released. Okay. If you have any question, I will be happy to answer. Thanks.
Yeah, I should also mention there was at least one more question, perhaps more in the last session, but there will be time for questions also after the 4 presentations. So this is just questions for clarification, for example, or urgent needs that you might have, but there will be more time. And please, if you happen to need to see the slides for the first question, is there someone who wants to comment on something in the slides? Because otherwise we will... Oh, we already disconnected. Okay, so... So if anyone has a question... One question. Adrian again.
Yeah, thank you for your talk, Adrian Friday, Lancaster University. So it looks to me like with the applications you measured, actually the bands between the spikes and the low demand or the typical demand is actually not that great. Do you think that's a representative set of applications? Are there other ones out there where there's a more kind of egregious thing, or is it... does it speak to something else, like the fact that people are using more cloud services and actually what's going on the device is not that interesting?
Thanks. So your question is whether the spikes are not so...
Well, I think the first one is whether those are representative, you know, whether you pick them, I guess, to be representative, perhaps. And the other one is whether there is a sort of trend to more offloading or something that means the actual energy footprint is going on somewhere else.
Okay, so the scenarios, with respect with the second one, the scenario that we test are the same. So we test the same functionality. So maybe in the implementation, between one release and another, there were some changes that affect this functionality, but the scenario that we test are the same. So, and actually, as in the cases with that there were a migration, the code was completely rewritten from Java to Kotlin. So in that case, for instance, in the first case, we didn't observe any change in the behavior of between the application written in Java and written in Kotlin. And the reason for that is that actually both Java and Kotlin is compiled to bytecode. And actually we think that maybe in that case, in that particular case, that they rewrite the application from Java to Kotlin, the bytecode probably will be quite similar. So in that case, the changes that they have introduced don't have any impact. However, in other cases that they have done a migration that took a lot of release, there we imagine that there were a lot of changes that affect the functionality that we were testing.
Okay, thank you.
Did you have a question? Are you standing up to ask a question? No. Okay. Okay. So thank you very much then. Oh, Oh, yes, it's a co-author of the next paper, ready to take photos. Okay, now I get it. Okay. Yeah, okay, so the last paper in the session, let's see if I can do this right. Pepane?
Works for me.
Dereus, who will talk about energy cost and machine learning accuracy impact of k-anonymization and synthetic data techniques. So, please.
Yes, so before I start, maybe two important things. First of all, the slides are quite full, but I hope to share them with you afterwards so that they contain all information. So maybe I will not discuss everything on the slides, but I will make sure the slides are provided. Second of all, not unimportant, Birgit mentioned to make sure that we have an outfit. Unfortunately, I think I will be the only presenter doing so, but I made the promise, so let me start off by changing. All right, and then we can start. With the energy cost and machine learning accuracy impact of k-anonymization and synthetic data techniques. So, well, this is me, a student of the Master Artificial Intelligence from the University of Amsterdam, and this is Anna. She was my supervisor for my bachelor thesis, and that's what resulted in this paper. Okay, so why should we bother in the first place? Well, we have the EU Green Deal, which makes a policy to reduce greenhouse gas emissions by 55% by 2030. And on top of that, we also have the GDPR, which, well, considers the protection of personal data. And what's interesting to this GDPR is that anonymized data is not is an exception to the GDPR. So what we don't know yet is what is the energy cost of privacy-enhancing techniques, such as anonymization methods, and what is the impact on the accuracy of machine learning, and what does it do with the energy consumption? So what we explored earlier was privacy-enhancing techniques as k-anonymity, and we will also include synthetic data in this research. So first of all, k-anonymization was first introduced a long time ago by Samatari, and one way to obtain it is by microaggregation. And what we do is we have the data on the left. Wish I could point at it, but then I don't have a microphone. We have the data on the left, so the 6, the 8, and the 5. And when we say that we want to obtain k-anonymity, we average these data points, and then we have the output to the right. And now, as you can see, we have 3 5s, for example, in the right column. So on the left, we have some unique values, which could be traced back to a person, for example. But on the right, for each value, we have 2 other values that are exactly the same. So we cannot distinguish those from each other anymore. And that would be microaggregation. We also have generalization and suppression, which was used in our research. And what that does is that it either suppresses information that can link back to a unique person, for example, addresses, which are unique, but also you could think of zip codes. And that's an example to the right. There we see unique values on the bottom. And when we have a k-anonymity of 1, that means, for example, we have 10, 9, well, star, and then those 2 values underneath cannot be distinguished from each other. So if we increase even more to a k of 3, then all those 4 values will be indistinguishable from each other. Okay, then we want to measure the energy consumption. We could do that with a hardware solution, as presented in the first presentation. But as you also might have noticed, it was quite expensive, and it requires quite some work to do that. So we used a software approach, namely RAPL, which is the running average power limit, which measures the energy consumption in Intel chips. And we use PyRAPL to implement this, which is a Python package that uses these RAPL counters to measure the energy consumption, which is actually developed together with the University of Lille and India. So that's where we are right now. And we see that it's not that very accurate, but it correlates up to 99 with, well, the hardware setup. So it is quite accurate. Okay, then related work focused on k-anonymization techniques. And last year was actually presented here also at ICT4S that the k value has a statistically significant impact on the energy consumption of the chosen anonymization algorithms. And generalization and suppression work better than microaggregation, so that's what we use for this research as well. and we found that models trained on generalization and suppression perform better. So that got us thinking, and we saw synthetic data was increasingly in the news, and that's we thought, well, why not compare it to synthetic data? So why would we use synthetic data? Well, because it enhances the privacy of data, and the promise is that synthetic data is similar to the original data set, so it would have the same statistical properties. And as far as we know, there was no research done yet on the energy consumption, so that was really interesting. Okay, so this is our experimental setup. We have two data sets. We have a baseline which we do not anonymize. We have a baseline which we use generalization and suppression to obtain k-anonymity. And then we have another factor which is synthetic data. And then we use 3 different machine learning techniques to see the impact on the accuracy and the energy consumption. All right, what we used for synthetic data is data synthesizer because literature showed that that was most accurate. And how it works, then again, I will provide the slides, so I'll go through it really quick, is that first it will analyze the data, then it will try to generate new data, and then it will test if it actually represents the original data. All right, so then we use those 2 data sets, and the following machine learning techniques: logistic regression, k-nearest neighbors, and a simple neural network. And we use the k-anonymity values of 3, 10, and 27, as the earlier work presented last year showed that those lead to the lowest or maybe even an improvement in the accuracy. All right, so then for the results, first we measured how much energy does it cost to either anonymize or create the synthetic data. This is what you see here. And what we see to the left is that for k-anonymity, and to the right for the synthetic data. And what you probably first notice is that on the right we see that synthetic data uses up to 4 times more energy than the anonymizing of the data. Sorry, it's a horrible word. Okay, so then first, maybe to make it a bit more interactive, if you think that 4 times higher energy consumption for generating synthetic data is acceptable because of the enhanced privacy, then maybe you could stand up to see what your thoughts are on this. And either no one agrees or no one knows how to stand up, but if you don't agree, then you stay seated, of course. Sorry. I'm sorry? Well, this would be maybe between using k-anonymity or synthetic data. Okay, that was not much of a success. Well, proceeding to the next results. The energy cost of training on k-anonymized data. Well, the 2 findings here are that the energy consumption and the training time decrease as the number that we use for the k-anonymity increase. So that's interesting. And also on the left bottom, you see every time the student performance set that we use, it was a very small data set. So those are really clustered on the bottom. Then for the synthetic data, what we saw is that there's very little variance in the measurements. They are really tightly put together. And that training on synthetic data uses more energy compared to k-anonymity, which makes sense because synthetic data, of course, mimics our original data set. Okay, then the accuracy impact. I didn't want to bother you with tables, so I used these horrible colors to show you. Then our findings are that synthetic data outperforms the benchmark, so no anonymization method for the student performance set. And for the adult data set, which is a bit bigger, we see that it underperforms on the benchmark, but it's just 2%, and that's compliant with related work. Then for generalization and suppression, we see that the k-nearest neighbors algorithm performs better on k-anonymized data than on the benchmark, which is probably due to some clustering effect, but there's still being research conducted on that. And that logistic regression and a neural net have a very similar performance, and well, it seems rather stable regardless of the chosen k-value. Okay, so take me home for synthetic data is that synthetic data consumes up to 4 times more energy to generate than to anonymize your data, and that the models trained on synthetic data perform slightly less or slightly better, but rather similar to the original data, which is good because that's what it should do. And then would you say that the benefits of enhanced privacy outweigh a 2% loss in accuracy? So synthetic data enhances the privacy a bit better than the k-anonymity, but yeah, the accuracy could be reduced by 2%. Would you deem this acceptable? So please, yes, if you stand up, and no, stay seated. All right. I think that's about 50-50. It would be interesting for the discussion later on. Let me proceed. So in general, the conclusions, the energy cost of privacy-enhanced data is lower for k-anonymity than synthetic data. And yeah, the energy impact of the accuracy impact of models trained on k-anonymized data is a bit inconclusive. It changes a bit, probably due to the data set. And the models trained on synthetic data have a similar accuracy and energy consumption than the original data, which is what it should do. And in general, techniques such as k-anonymity and synthetic data could enhance privacy. But the most important finding of our study was that it can also actually improve the energy consumption without any accuracy cost. So while they might seem two orthogonal directions, energy consumption and privacy, they actually could go hand in hand. All right, and then this would maybe be for the discussion. Thank you.
So I will ask all of the speakers to come and take a chair and perhaps pull it a bit forward because on the stage. And while they do that, I have a poll of my own. So if you think that it is tiring to sit down for an hour and that your blood circulation would sort of increase if you stand up, then I think you should stand up now. I think everybody should. Just to get some fresh oxygen into the system. Great. Ja, gör det. Okay, so thank you. I actually thought that it would be nice to ask the panelists if they have a question or a comment on some of the other papers in the session, and we have to give you microphones. There are 3 here altogether. Okay, so perhaps you guys will share one and you will share one and I keep this. Okay, so is there something that someone would like to ask someone else here? Yes.
Yeah, I can start. Well, I have many questions. So maybe for Matthias first, about Kotlin and the energy efficiency of this programming language. Did you study if the expertise of developers in using Kotlin compared to Java have an impact? Because Java is here for 20, 30 years ago. We have many studies about Java efficiency, what collection to use, while Kotlin is more newer. So does this have an impact?
So we haven't checked in this experiment the experience of developers. We haven't asked them the experience of developers, but in a previous paper we have done a study with developers that have migrated applications from Java to Kotlin. And there, one thing that we have seen is that many of them, of these developers, were using Java and they migrate the applications because Kotlin offers some features that they didn't find in Java. For instance, functional programming, especially for development in Android applications. And we have seen that a lot of these developers that migrate Java to Kotlin, they were the developers with large expertise in programming languages, and they search for these features that Java doesn't provide. So particular features that they couldn't find in Java. So, but with respect with this study, we didn't interact with the developers, actually.
Did you have another question, Adele, for someone else?
Yeah, but I don't want to monopolize. No, I had a question for Jens, about the measuring all the different components, the TV, and so use smart plugs to collect it. So in our research team, what I also do is I try to model the power consumption of connected devices, like a TV, like a screen, like a computer. Did you think about modeling it? So instead of having these power plugs everywhere, you can have an estimation model And therefore you can scale up without using hardware device to measure and reduce e-waste.
Well, I want to measure, that is, the real measurement. But I think the smart plugs, they cannot measure low power. Then I had to use my professional multimeter. And that was really good because then you can measure all these and see what happens. I saw a lot of fun things. You were talking about laptops. So for my workplace, I discovered that the brightness settings of the display was the easiest, the largest impact. So this display went from like 16 watts to 38 watts or something. And I'm a bit old, so I want to have it quite bright. So I'm at like 33 watts. Yeah, I have a question for you back then, because you measure laptops, and I ask you. I thought, okay, I saw just the number, but you clarified it was so 10 was 10 watts then. But it was not the whole laptop. It was like the CPU or motherboard, or was it? So it's not what actually goes into the just part of it. And I also have the same question to you then. You also said this is but it was a mobile platform. So was it milliwatts then? It only said like 85 or something. It cannot be watts, right? So it has to be milliwatts.
We measure all in joules.
Hmm?
In joules.
Okay. All right. Not much.
Yeah, I imagine both. Actually, what we did is we wanted on real-time energy measurement without any physical device. So we had we used similar one as what you use, RAPL interface on Windows, on a Mac, and we built our own tool to collect this metric and provide it to the user.
Mm. Okay. Yeah, it's good because you can measure what's inside the computer, but for me I want the energy.
Okay.
And the losses of the power conversion and everything. So in the end,
because it's part of our research in my research team. What I specifically do is try to measure inside a computer what's happening. Every component, every hardware component, CPU, GPU, every software, every source code. So we're
okay. I think that we will let in the audience. If you have any questions for one or more of the speakers, we have one hand shot up quickly over there, and then 2 and 3 and 4, 5, 6. Now they're everywhere. So you can decide the order, but I think Adrian was first and then up on the top row. And please, again, state your name before you ask your question.
Okay, well, thank you, Daniel. Adrian Friday, Lancaster University. So I want to ask a question to everybody, if I can, to get the maximum bonus points from Daniel. What this says to me, at a time when what we need is exponential decarbonisation, and there are growing AI, growing metaverse, growing blockchain, growing numbers of users, growing numbers of non-user devices connected to the internet. These all sound like either there's a gradually not much change, or as the versions go up, the thing gets a bit heavier. But then there's these other things. So I want you to reflect on what is meaningful to measure if what you really want is an exponential decarbonisation.
Tough question.
Yeah.
Keep measuring and see how you progress, of course. I know I realized that the new Apple Air I have is really efficient. Average around 6 watts. It's hard to push it above 10 watts. I also measured the old PC laptop. Now I'm making maybe commercial here, but that consumed more than twice as much, so 14 watts on average. And I also noticed something happened with the Teams video conference, because then it was like 10 watts added or more on average, but it suddenly dropped. And I think Microsoft did some software tuning and stuff there that actually reduced the Teams video conferencing. They claim, I think, half consumption now compared to 2 years ago or something. when they have done all this, which is good, of course. If I compare my work laptop now versus my old, when I started working, it's like consume just a few % of what it consumed. And in terms of computational power, it's like 500,000 times better. But of course, who cares about the computational power? For us, it's more the power. And the good story here is that, yeah, it consumes less than 10% now.
You could argue that they've also massively shifted to become a cloud business and put more stuff. I mean, they have made those devices better, right? But there's a lot more going on elsewhere, isn't there?
Yeah, we reduced the data centers with more than 40% now since 7 years ago. So the cloud is also going down, for us at least.
So we should buy new computers to save energy. And keep on measuring. Yeah. Okay. Do we have someone else who want to answer that critical question? Yeah.
Well, maybe more from a data perspective. So what we looked at was more the energy cost of machine learning. And there we found that generalization and suppression, as just mentioned, can actually greatly reduce the energy consumption. So you could say, well, that's a good thing for anonymization techniques. On the other hand, you could say if we store our data differently, then we probably have the same result. So those may be also design choices, and it could require some further research, but it greatly impacted the energy consumption. And then if you combine it with, well, the other applications, then it could be that you, well, reduce the energy consumption of IT in the end, I'd say.
Okay. Well, I have a different, similar perspective, but differently. What I try to do in terms of energy efficiency and software and hardware is not just to save the planet. There is other needs. We need we need to optimize the battery usage. We need to optimize resources, which also power is a resource, which is we think it's infinite in some part of the world, in other parts it's not. But also what we saw in this morning in the keynote and yesterday in the workshops for people who are here is if we have a device that's still running smoothly and efficiently and the battery going on, we can extend the life of our devices and therefore reduce the renewable rate of devices and therefore have a bigger impact rather than just on power consumption directly.
Yeah, so I agree with Adele. So for me, in this case, so I came from the discipline of software engineering, and we focus on quality of the application. So for me, to measure the energy consumed by one application is actually a way to measure the quality of the application. So for me, it's a dimension more in the quality assessment of one application. If one application consumes more that it should be, so for me, it's an application with bad quality, and it's an issue that we have to solve.
Okay, so there are several questions, and I think top row, number 2, and then there, so could we, we only have one microphone, yes, now in the audience. Yeah, so you have to run all the way, Vladimir.
Sholo Yediji from LE2 University of Finland. Thanks for the insightful presentation. However, I kind of see a contrast. This morning we had a very good keynote talking about changing business model and how we should go towards sufficiency and all. And Jens, in your presentation towards the end, you said, a new game is coming out. I'm thinking of changing my PC. So how do we develop strategy to move towards sufficiency, basically? Are we going to say because energy price is dropping, things are becoming more efficient, we should consume more? So what are the strategies, basically?
Was that directed at someone in particular or all of the...
all of them, but I want to start with Jens because his slide prompted me to ask that, actually.
Okay.
Well, I mean, the takeaway, I guess, from my measurement is that, well, a big TV and a desktop gaming PC, that's a huge, they are consuming quite a lot. But all the other things are actually very efficient, I would say. Smartphones, laptops today, even a lot of data center services are very efficient. When you talk about data, the one that costs is, what is it? The cost of the gaming PC is the graphic cards. They do a lot of processing. We see that also in the data centers. When we do processing, that and simulations and stuff like that, climate models cost a lot to run, for examples. But just streaming or just music, videos, things like that don't cost. And it's not that cost for Facebook or Google as the keynote was about. It's actually all this data processing and closer. All right. And okay, since you mentioned the keynote, I have to mention that a lot of the figures in the keynote are wrong because it's not based on measurements. So when we do the ICT carbon footprint and energy footprint, we base it on measurements, and then we see it quite stable, actually. Maybe going up a little bit, but if you take it also including consumer electronics and TVs and that, then it's actually going down. If you include the paper industry, it's going down. That industry is going down because of the online and things like that. So just a reminder on be careful what I mean, the figures. They need to be good.
So there were several more questions. I don't know if anyone else wants to answer, because otherwise I will allow the audience, once someone wants to have a take at answering the question. Because
my question about strategy, I will still like the panel to talk about that. So if we are saying we improve efficiency and all of this, does that mean we should consume more? If a new game come out tomorrow and because my graphic card is bad, what are the strategy? We are all researchers here, so I would like to know your insight. What strategy should we, involve when we design games or when we design hardware to, reduce this amount of consumption? E-waste is a big problem. Yesterday we talked about, colonization and all that. Today I feel like we are the modern slave of these big tech companies. And e-waste is one big, huge issue. So should we continue to consume and have more e-waste? That is a big problem in different parts of the world, in Asia and Africa.
I think this is slightly similar to the previous question. So I will actually allow the three other panelists to choose if you want to answer, because there's a clash between worldviews here right now. And I'm not sure that I don't know if you can or want to, because this is a question at another level than your research that you presented. So I will allow you to choose if you want to have a say.
I will try to.
Okay.
So what we tried to do with our research was more to make the data accessible and to sort of understand this, how it's working, this energy consumption. And also to present it to you, but also to laymen. And I think in the end, it would be a discussion. So in my opinion, I'm not the one to answer your question, but I think these are the sort of moments where we can discuss that, and then we should define a policy on that. But I don't have a strong opinion on this, on what we should do, to be honest.
Does anyone else want to?
It's the same thing. I think as researcher, we're trying to show you how to measure what's the impact, and then it's up to society, to people to decide what they want in the future. I think it's more a social decision.
Yeah, similar for me. In this case, in my case, the people that work with me, we are trying to understand what is happening in the industry, in particular with the transition between two technologies, and try to understand in terms of, in this case, energy consumption or quality or whatever. But in this case, we are trying to observe what is happening and try to understand if whether this transition, this change between two technologies has an impact in the environment or not. But that is.
I just want to comment that I think that what we're seeing now is also a discussion at the higher level of what ICT4S, the conference, has been and is and will be. But I'll leave it at that. There were many arms up, and we have limited time. So some people raised their hands for the third time. or whatever. Several questions here along the row. Please choose Vladimir. I don't know who was first.
It's not a question, it's just a remark, Jens. You must consider the figures I presented are not the ones you would like to see. But I'm not saying your figures are wrong, so please respect what the others do, okay? And the last study I've seen has been made by the ADEME in France, and it shows that the trend of the digital sector in France is going to be a growth of 45% of the carbon footprint by 2030. I'm not the one who made the study. So maybe we're all wrong, and you are the only one who is right, but that's life.
Well, sorry if I came out like that, but in the end, we must rely on, I mean, PC sales peaked 2010, and since then, it's going down. And then the share, it's much more laptops now, which is better, of course. TVs also peaked around 2010, so going down, which means, and they are also, if I compare it to my old like TV, it was much heavier, consume much more. Yeah, the total weight. Yeah, but the total weight of what is produced is much less today, and we don't produce more. I mean, it has been mature. It's quite mature today, and I think this is missed. It's all wrong. You mean this? The market statistics is wrong, and my measurements are wrong. I mean, yeah. And sorry, Dan. I mean, how can I convince you? I mean,
just to add maybe something. Even if it was stabilizing or slightly decreasing, like IPCC tell us that we need to decrease by 7.6% if started in 2020 every year. So I would be quite keen to see such a decrease every year in the direct impact of ICT, at least, even if it's stabilizing, which I think should be questioned.
What if I mean, the network operators and data center operators, they run in Europe, nearly 100% of all the operation is from renewables today. You can discuss if that's credible all over Europe, but for most part it is. So, I mean.
So I think.
Yeah.
Okay, Vlad might have an answer, so I will allow. There's someone else who is raising his hand every time.
I have the mic. So. I'm going to just make a comment since I already have a mic.
Okay, we only have one microphone, and I will allow you to ask since it's in your hand. You were sitting right there, but there are 3 more questions, and that's it. And please phrase it in a way that can, a short answer would suffice.
Yeah. Just a comment that while an individual household can remain steady or decrease, the number of devices on average per household are growing. So that explains the differences between 2 opinions.
Okay, number of devices is increasing. So we have one comment here or question and then one more, and that's it. And I want to say something before you leave. So please state who you are also before you ask.
Yes, so I'm Arthur Ferret, working for Broadpeak at internship. And so I work on power energy consumption from video used data centers. And I found something very interesting on your presentation, Jens, about the energy decrease of standby devices. And that is true for like laptops or most household computers, but what we know in data centers is that most of the time servers are kept powered on, and while they're powered on, they still consume like a lot, a lot, like ranging from 100 watt to 500 watts, depending on configurations. And it's really rare that we power off the servers, so even though they are not used for high computational tasks, data centers used for streaming or video, they keep being powered on, and that standby that's not, there's no decrease in the standby power consumption for these servers, and they keep being powered on. So even if we do not talk about baseline energy or the manufacturing cost or whatsoever, we know that this service costs all the time, even if people are not using them in most data centers. So that was just a comment on it. So thank you.
Short answer?
I get all the
yes.
Yeah. So, I mean, I think if you look at like very efficient platforms like Netflix, of course they have the scale. Then it's not much. It's like 1.5 kilowatt hour for the average Netflix subscriber, including also they include the Amazon in-sourced platform they're using. We see ourselves that we used to have a lot of small data centers, data rooms around the company, around the world. 10 years ago, we started to be more aggressive and try to. So now we built 3 data centers, but after a few years, we realized we only need 2. And today, all the servers consume much less than they used to do. We try to run them as efficient as possible. I think in this case, it's not the Google and the ones that, it's all the small companies and small that still sits with their own servers, that they are not as efficient. The other ones are pretty efficient, I would say. And we try to make sure to run things on them, what we have.
So there were several people who have had their arms up, but we have to wrap up. I will, however, allow one last question or comment from Vlad, because I suspect he might be able to add something with his expertise, and because his dark, beautiful voice is a nice way to end.
Thank you. So just one, I would have many things to say on numbers, but just on end devices, because this came, I think this one point where there is not necessarily a contradiction between Jens and Hugues. In developed markets, the number of devices peaked and is going down actually, and they are becoming more efficient. And it's not only Jens saying, it's also Fraunhofer said this. In Germany, for example, yes, okay, but
electrical.
So I'm just saying it's not only Jens saying this, it's also Fraunhofer. You might have different examples, right? It's the Swiss Ministry of Energy seeing the same in Switzerland. So end devices in developed markets are decreasing. Their number has peaked and the energy consumption is clearly going down. This is not a worldwide phenomenon though, because other markets are still increasing. So that's why I say this is not necessarily a contradiction, but and as yet says this is national statistics. So I mean you can not like them, but
okay,
we are all scientists, so we should look more for the facts and
yeah, but go on, because what was your comment?
So my comment was that it's not necessarily a contradiction with end devices. What Jens says, he refers to developed markets. And what Hugues said, I think, is worldwide, and that's indeed still growing.
Okay, so thank you very much. I will wrap up. I will say one thing about, again, this goes back to Jens. I just wrote a comment here. It's like, I thought it was interesting to hear your presentation, because usually people say like this study or this paper, but he answered most questions with, in my family. You know, that's an unusual way to answer the questions. Also, I have an announcement from the organizers. Someone forgot a phone here in the previous session, and if you're missing your phone, you should. Oh no, it wasn't here. Oh, it was this morning in the keynote. Okay, so if you're missing your phone, you can go and look for it in the registration. This discussion turned out to be a lot more exciting with lots of feelings here in the room than I would have thought beforehand. And I'd like to thank you all, the presenters, as well as everyone in the audience. So thank you very much. And there's a break now. And then there are the poster session. Yes.